Welcome back. This is part 2 of series where we're creating a custom layout for Jetpack Compose, and we're trying to create a layout where we can lay out nodes in a graph with arrows as edges. And the last part we learned how to draw arrows between boxes and make them look like they're intersecting rectangular nodes with an arrow that looks like they are aiming for the center of the box, which is what we will use in this part. I created a new file called nodegraph.kt and added a new main method that we will use in this part. When we run this, we will just have an empty canvas to put stuff into. So a layout in Jetpack Compose is just the code that decides where on screen things will be painted. And as an example, we can look at the built-in layout column. And the column is a layout that takes items like, let's say, text like this and lay them out on the screen in a column. So the result for this is just hey in a row like this. But we want to lay out a graph, so we need something that models the graph itself. For example, if we were to have some nodes that we want to lay out. So let's say that our nodes are of the type string. We can have some string like hello, Kotlin, or the world. And a graph is a set of edges, and edge we can model as a start point and a end point. And they need to have some type. I don't want to lock us into any specific types. I will make this a generic of type T for the edge. And let's also make a class for the graph itself. That will also be of the type T, which is a node type. And this will take in some edges in the form of a list. And let's create some edges when we have the classes for it. So the edges will be a list of edge from a node in the node list. Let's say from node 1 to node 0. So that is a node from Kotlin to hello. Let's add some more, like a node from Biritum to hello, and from the world to both Kotlin and hello, like that. And also create the actual graph. It's a graph with edges. And before we start with our own layout, let's use our nodes as or create items for our nodes. So for each node, I want to create a text item that will be our nodes, and we will have the it as a text since it's a string, and I will add some modifiers to it. For example, I want the background to be of a color. You choose any color here, but I will put in maybe light gray. And also I want a border with a width of 1 pixel, and let's make color black, and also let's give it some padding around the text, like 4 pixels. So now if we render our nodes in our column layout, they will look like this. Now we can start creating our own layout, and I want just replace column here with something like node graph, which would be the name of our new layout, and give it a modifier. We create that function. It will be composable, and will take a modifier, and it will take content that will be of a composables. And when we create our own layout in Jetpack compose, we have to say layout. We just give it the modifier. I actually want to have a default value for the modifier here, like this. And we also give it the content as the first parameter. The layout also takes a lambda here. This lambda takes a few parameters. That takes modifiable, which is the items that we want to lay out. And it takes constraints, which are the constraints around where we are allowed to lay out items. And the layout are divided into 2 phases. The first phase is measure the items, and then we lay them out. So if we take measured is the modifiables that we do map. We just measure with some constraints. I don't want to constrain them like here. Constraints. And then we do the layout. The layout needs some constraints that we have the max width and the max height. And a lambda where we do the actual placement of the items. And we want to place the measured items, and for each measured item we place it relative to top left corner of the window, and we'll place it at X, Y. And I want to be able to vary them. So if we start at Y equals to 0, and then for each item that we lay out, we say Y, and we add the height of the measured item, then we should have created something that's very close to the column layout. But we want to lay out our items as a graph, and to do that we need some more information from the graph itself. So we will take the graph as an input parameter here, and the graph is of type T, so we make this function also a type T, and we have to send it in to our layout here, the graph we have. We also need to be able to know which items are rendering which nodes. So we set the layout ID of the modifier here to the node, which is it. Now we have the information inside our layout. And here, instead of creating a list of placeables, I want to create a map. So I will use associate method that will associate the layout ID that we just added to the items. And we know it is a T. And we want to associate it to the measured item. So this now returns a map from nodes to placeables. Then I want to delegate the actual placement or the calculations on where the nodes should be placed to the graph. So I tell the graph place nodes and give it our measured nodes that are mapped to the nodes themselves. Let's create this function. This we need to import. So our graph consists of nodes and edges, and the edges are directed. So I want to divide our nodes into layers. So all nodes that have dependencies on other nodes will be put in a layer below the other nodes. So I will create the layers in a method, and let's call it create split into layers. And we need all the measured items, but only the keys, which are, in our case, the nodes. So let's create that function. This function will return a list of lists of nodes. And it takes all the nodes in. This will return the collected layers, so which will be a mutable list of nodes, and we will iterate and to start with. We will have a current layer, which will just be the nodes that we have, but I want it to be a mutable set here. And then I will loop until the next layer is empty, or is not empty. And the next layer will be that we look at all the edges that we have and figure out which edges have something in the current layer, or rather where any edge have its endpoint in the current layer. If it do, we will pick out the start nodes and push them down to the next layer as a set. Then we take the current layer and just remove all nodes in the next layer and put the collected layers. We add the current layer. So now we have removed all nodes that should be moved down one step. And then we set the current layer will be the next layer as a mutable set. And this will be a list. This is a simple algorithm, and be careful, it do not handle cyclic graphs. So if you have those, you have to extend this layering algorithm some. Now we have the layers. So we can take each layer in layers and layer them out. So if we have our X and Y as a start point for the first layer, let's put them in 30 pixels from the edges. So now we can say the layer for each node in each layer, we will place the item in a rectangular area where we put it at X and Y. And we know how big each item is because we have it in the measured parameter. So we take the measured for each node. And we just add that to our X to get the width and the height of the measured item. Now we see some warnings here that item might be null. So I will instead use this question mark dot let, so that if item is null, we will kind of ignore it. Otherwise, we will use it. So this will be where the node will be placed. And for each node, I want to add the width of the items. And for each layer, we will add, for now, just say 60 pixels. Now we have figured out where to place our items, but now we have to tell our layout function where we have decided to put them. So I will create a few properties on our graph. First of all, a map of node positions. This will be a mutable map of from node to int rectangles, and it will be a mutable map. So in here we will put our nodes. So we map our nodes to their positions in this map. And we will create another property called positions in here, which will be a mutable state flow. And that will contain the map of the two. We only need the offsets to place things, so we will save the offsets in here. And that will be the empty map to start with. And then we expose a public property called positions. It will be of type state flow, the same type that we have in here. And that will be just positions. So this is using the state flow mechanism to generate events out of this model object. So after we have placed our nodes, we assign positions.value with our node positions, but we will just extract the top left corner of each item. And we will need to have it still as a map, so I will map the values. So we keep the keys, but change the values of this map and assign it to positions, which will generate events out from here that we can pick up in our composable item, composable function. And we do that by say, let's placed items will be the graph, the positions, and we will collect them as a state to this variable. And now when we use this placed in here, it will automatically update whenever the graph is changed from either our code or from this place nodes call. And we can just say placed, and for each, and this will contain the keys and the positions. So we pick out the measured from the key and say place relative at the position. Okay, so this can be null. So I will just do this for now. There we have our graph in layers, but I do want them to, I want some space in between the nodes, and I want the nodes to be centered over each layer. So let's do that. I will start by adding some padding. So let's do horizontal padding equals to, let's say 30, and vertical padding as 60. And I will add the vertical padding here and the horizontal padding here. And we also want to add the layers, so if I take all the heights in this layer, or 0 if it's null, and then I take the max value of that, so we add the padding and the height of the highest item in the layer. Then we have some spacing, and to make the layers centered, we need to figure out the width of each layer. So the width of a layer is, we can calculate like this. We create a function, and it will return an int. So we calculate it by saying the layer, and we map it to measured dot width, which can be null. So we say L is 0. And then we take the sum of it, and we also add layer size, so -1 times the horizontal padding, because there is one less gap than there are nodes in a layer. So that should be the width of a layer, but we also want the widest layer. So we take all the layers, map it to layer width, and the measured, and we take the largest one. So now I will put the starting x value of each layer to be the widest layer minus current layer. I'll divide it by 2, and then the items should be centered. Now we're only missing the edges or the arrows between nodes. And we learned how to render arrows last part, so let's put that into use. In our node graph, we have this modifier over here that we can use to draw on our composable after we have laid out our items. So we will say draw with the cache, and this forces us to use the draw with content method in here. So we say draw content. That will actually trigger the drawing of the content. And after that, I want to draw the arrows. And I will ask the graph to give us the arrows. That's arrows. So let's create that function. I want this to return a list of arrow. And arrow will just be a class that holds the start position and the end position of each edge arrow that we want to draw. So we will have our arrows, that is a mutable list of arrow, which is what we will return. Each edge will result in one arrow. So we say for each edge, and the edges will go between two nodes. So we have the node positions that we calculated earlier, where we have the rectangles of the nodes. So we will take so this is the edge. So it's the edge start, which this can be null. So we will use the let function. So this is a start rectangle. And we will do the same for the end rectangle. So now when we have the rectangles, we can calculate the start position using that intersect rectangle method that we wrote last time. Intersect rectangle. So we have the start rectangle and the center of the end rectangle to offset. And we do the same for the end point, which go from the end rectangle and the center of the start rectangle. So this will be an arrow. So we add that to our arrows. Add arrow, start to end. And now when we have our list of arrows, we can just say for each draw an arrow. Let's make them blue from start to end. There we have our nodes laid out in a graph and arrows as edges between the nodes. Thank you for watching. See you next time.